Alright, so the first problem is going to be log base 4 of 1024 equals 5. Did everybody get that? Number 2, log base 125 of 625. Number 3 tells you to evaluate the logarithm, so you make it equal x. You drag the 2 over. 2 to the x power is 1/8. It's -3. 2 to the third power is 8, and for it to be in the bottom of the fraction, it would need to be a negative. Log 749 is 7 to the x equals 49, so x is 2. Number 5, the base is 10. It's 10 to the x equals 1/100. It's easier for me to write it as a fraction, and I know that x has to be -2. 10 squared is 100, and for it to be in the denominator, it would have to be negative. Write the equation in exponential form, so they're wanting you to pull that over and write 32 to the 3/5 power equals 8. Do you have any questions on the first 6? 7, state the property. It's the quotient property. 8 is the product property. 9 is the product and also the power property. 10 says write the expression as a single logarithm. The first step is to put the 4 back on the t and the 5 back on the w. So the first step is log base b of t to the 4th plus log base b of w to the 5th. The second step would be to transfer from and adding to multiplication. Log base b of t to the 4th w to the 5th. Addition translates into multiplication. Okay. 11 is subtraction, which translates into division. Log base 12 of 42 over 6 is log base 12 of 7. Number 12, the 4 goes back on the x and the 6 goes on the binomial. So I have log of x to the 4th minus log of x plus 2 to the 6th. That translates into division. Log of x to the 4th over x plus 2 to the 6th. Thirteen says expand the logarithm, so they want you to do the opposite of what we just did, and that division would translate into log base 9 of b minus log base 9 of 6. Number 14, I want you to separate the 5 and the b squared first. So it's log base 7 of 5 plus log base 7 of b squared. Then you need to take it one more step. Log base 7 of 5 plus 2 times log base 7 of b. This is equivalent to saying the log base b of 57 over 74 to the 1/2 power. So it would be log base b of 57 to the 1/2 minus log base b of 74 to the 1/2. Then I would pull the 1/2 over. 1/2 log base b of 57 minus 1/2 log base b of 74. Use the properties of logarithms to evaluate. Addition translates into multiplication, so this is log base 3 of 9 times 36, and then divided by 4. So what is 9 times 36 divided by 4? 81. So this is log base 3 of 81, and they want you to evaluate it. So they want you to go ahead and get an answer for it. So 3 to what power is 81? And that is the 4th power. Mm-hmm. Next page. Solve. Well, this is base 10, so the 10 picks up the 3. 10 to the 3rd power equals 3x plus 11. What is 10 to the 3rd power? 1,000 equals 3x plus 11. Subtract 11. 989, is that right? Equals 3x. Divide by 3. X is equal to 989 over 3. That's how the book has the answer left. You could turn it into a decimal if you wanted to. Questions on that problem? 18 says solve. This 3 needs to be put back on the 2x, so this says, right here, log of 2x to the 3rd equals 4. That means 10 to the 4th equals 2x cubed turns into 8x cubed, so it's 10,000 equals 8x cubed. Divide by 8. 10,000 divided by 8. Root. So I need to raise that to the 1/3 power. So x is equal to 10 point, does it say where to round it to? 10,000. 10, 100,000, 10,000. 7, 7, 2, 2. That's how that rounds. Bless you. 19. Write it as a single natural logarithm. The same properties apply to natural logs that apply to logs. So the 3 goes back on the 5 and the 4 goes back on the x. So it's the natural log of 5 cubed plus the natural log of x to the 4th, and then you multiply them. It's the natural log of 125. Where did I get 125? Okay, so this is my answer. Same type problem. Put these on the natural log of a to the 3rd minus natural log of b to the 3rd, and that is really the natural log of a to the 3rd over b to the 3rd. That is your answer there. 21, e to the 3rd power. Just put that in your calculator. E to the 3rd power. And what is that? Oh, no, natural log of that. Natural log of e to the 3rd power. It's 1. But this is what you need to do. It's 3. The 3 goes over here. This is 3 times the natural log of e. Natural log of e is 1. This is really 3 times 1, which is 3. Separate that first. I had it typed in my calculator wrong. I should have typed it in natural log of e to the 3rd, all in parentheses. Then it would give me the right answer. I put the parenthesis in between it and messed it up. An initial population of 820 quail increases at an annual rate of 21%. Write an exponential function to model the quail population. Well, here's your function. You have 820 quail, not kale, but quail, and it's going to increase 21%. So next year, are you going to have more than 820 or less than 820? More. Well, if you just multiply it by 0.21, you're going to get the 21%. You're going to get the amount that you have that's new. What do you have to multiply it by in order to retain everything you have and show an increase? You have to multiply it by 1.21 to the x power. So if it's a growth, it's 1 plus whatever it is. If it's a decay, then it's 1 minus. So this is my function. 23 says, find the annual percent increase or decrease. Okay, this is where you need to look, right there. Yes, ma'am. Okay.
What do you write
If it decayed, let's say it decayed 21%, then you would write 820 times, what is 1 minus 0.21? 100, you know where the 1 comes from, right? That 1 right there is 100% of what you have right now. You keep everything you have and you put an extra 21% with it, okay? So if I'm going to decay it by 21%, I'm not going to have the 1 out front. I'm not going to have 21%. I'm going to lose 21%. Well, if you lose 21%, what percent do you keep? You keep 79%. Does that make sense? So in there you would have 0.79 to the x power if it were a decay. Okay? Now, remember what I said. Is this an increase or a decrease? Well, if that number is 1 or larger, if it's 1, we don't change it all. If it's larger than 1, it's an increase. If it's smaller than 1, it's a decrease. Is this larger than 1 or smaller than 1? Larger. How much larger? How much bigger is 2.3 than 1? 1.3. If you were to write 1.3 as a percent, what percent would it be? 130. So this actually had an increase of 130%. Then it would be no change at all. Okay? If you had 820 quail and next year you had 820 quail, it didn't go up, it didn't go down, it stayed the same. So it didn't increase or decrease at all. And that could happen. Okay. Well, what if this had said, then what would be your percent increase if it said 1.25? What percent would you be going up if it said 1.25 here? 25%. Well, how much bigger is this than the number 1? It's 1.3 bigger. Okay? 24. For an annual rate of change of negative 31%, find the growth factor or decay. Are we going up or down if we're growing or decreasing? What are we doing if our change is negative 31%? You're decreasing. So it's a decay. What would you write in your equation? Let's say you started with 820. What number would you put in there? Are you going to have more next year or less? Less.
So it would be negative 31?
No. That's how much you're losing.
Oh, okay.
How much how much of the original are you keeping? That's what you want to know. So if you're losing 31%, what percent are you keeping? Not 59. 69%. Okay? So your decay factor is right here. Okay. 25. The half-life of a certain radioactive material is 62 days. An initial amount of the material has a mass of 186 kilograms. That's how much I'm starting with. Write an exponential function that models the decay of this material. Find out how much radioactive remains after 13 days. So it's cutting itself in half every 62 days, but you've only gone through 13 of the 62 days. So your exponent is 13 over 62. So let's put that in. 186 times 1/2 raised to the 13 over 62 power. Is that 1/4? No.
Wait, how do you get 13? Oh, okay.
If it was, it's going to cut itself in half every 62 days. We haven't done it. We haven't cut ourselves in half yet because we haven't gone a full 62 days. We've gone part of 62 days. What part have we gone? 13 of them. So my answer is 160.840 kilograms. Suppose you invest $1,500 at an annual interest rate of 3.2% compounded continuously. A equals PE to the RT power. That's your formula. PERT formula. P stands for your principal, which is $1,500. E to the power of the rate. What's the rate here? So how do you write it over here? .032, and it gets multiplied by 25. Everybody putting that in their calculator? So we get $3,338.31. $27. How much money is invested at 5% compounded continuously for 3 years, yielding $820? Same formula. This is the amount you have at the end. The principal is what I'm looking for. E to the power of 0.05 times 3. So what do you think we ought to do here? $820 divided by e to the power of 0.05 times 3. You just divide both sides by e to the 0.05 times 3. And P is equal to $705.78. Okay, the table shows the number of squirrels in a particular forest T years after a forest fire. Explain how the population of squirrels is changing each year. What's happening to it, guys? Doubling. Write a function to model the situation. Explain what the numbers mean. Okay. How many did you start with? You need the starting amount times. We don't want to call it a rate because that indicated to be linear. It's called a growth factor. And your exponent is time. So how many did we start with? At the beginning of this story or chart, how many animals did we have? 25. And what did we say it was doing? Doubling. So that means we needed 2. So 25 times 2 to the t power. So you need to indicate to me, you have to tell me that 25 is your starting amount, that 2 represents a growth factor of 2 because it's doubling, and t represents time or number of years. Any questions on that one? That's all. That's it. That's all they ask for. Okay, last one. In a particular region of the national park, there are currently 390 deer. The population is decreasing. We're going to have more than 390 or less than 390? Less. At an annual rate of 13%. Write an exponential function to model the deer population. Remember that this starts with starting amount, growth, or decay factor, and then time. So how many did we start with? 390. What's the growth factor? And I think growth factor is the right word. If the growth factor is 1, what's happening? If the growth factor is 1, what's happening? If I multiply 390 times the number 1, what answer do I get? So if the growth factor is 1, is the population of my deer changing? No, it's not changing. Well, they told me it was going up or going down. Down. How much? 13%. So I'm losing 13%, but the question that you want, every time they tell you that, you want to get yourself trained to automatically say, if I'm losing 13%, what percent am I keeping? I'm keeping 87%. Okay? So that's your growth factor, is 87% to the power of x or t for time, whichever one you choose to use. 390 is the initial population of the deer. The decay factor is represented by 1 minus the 13. That's how you're getting the 0.87. To predict the number of deer in 5 years, what would you do? What would you do to predict the number of deer in 5 years? Well, 5 years is, what are they talking about there? The number of deer? They're talking about the growth factor? Or does the number 5 represent a period of time? So where do you think it should go in your function? So this would be 390 times 87% or 8700 to the 5th power. And I'm going to have approximately 194 deer in the region.